In this demo, I'll walk through the architecture of our autonomous agentic wallet system and then demonstrate real DeFi interaction, wallet management, and policy enforcement on Solana DevNet. This system is designed as a secure execution kernel for AI-driven financial agents. Architecture overview. At a high level, the execution flow looks like this. An agent calls decide and produces a structured intent. That intent is validated using Zod to ensure strict schema compliance. Next, the intent is passed into PolicyEngine.evaluateAll parents. If any policy denies the intent, execution is aborted immediately. If all policies pass, the intent is routed to the appropriate adapter. The adapter builds the transaction. The transaction is passed to the signer. The signer retrieves the private key securely from the KeyStore boundary. Private keys never leave this boundary. The signed transaction is then sent through the adapter. The adapter confirms the transaction on-chain. Finally, the system returns an execution result containing the transaction hash. This creates a deterministic, secure, and auditable execution pipeline. To demonstrate AI-compatible execution, I'll use our CLI-based raw intent runner. I run this command. This simulates how an external AI system would submit a structured intent for execution. Now I'll open the swap.json file. This intent contains the intent type, which is swap in our case, the source wallet ID, the Orca Whirlpool pool address, token input mint, token output mint, amount and minimum expected amount out, a reasoning field for traceability. This reasoning field demonstrates explainability. The system can attach context for why the trade is being executed. Back in the terminal, you can see intent validation passed. Next, policies are registered, including the spending limit policy and the rate limit policy. Wallets are loaded securely from our encrypted file store. The intent is routed to the executor. The executor identifies the agent and routes the swap intent appropriately. The policy engine evaluates all active policies. Both spending limit and rate limit pass. Now the TX builder requests an Orca swap quote. We can see the pool address, the token mint, the input amount, and LAM ports. The Orca quote is received successfully. The estimated output amount is logged. Next, the transaction is signed. Notice, the executor logs transaction signed. The signer also logs transaction signed. This confirms that signing occurs strictly within the signer boundary. Then the Solana adapter confirms the transaction. We receive a transaction hash. The executor logs that the pipeline is completed. Finally, the raw intent runner logs execution successful and provides a Solscan Explorer URL. Opening the Explorer, we can see the on-chain swap executed through Orca Whirlpool on DevNet. This confirms real DeFi interaction, not simulation. Now I'll demonstrate wallet management for agents. First, I list all tracked wallets. We see 3 wallets along with their public keys and SOL balances. Now I'll create a new wallet. The system generates a new wallet securely and stores it in the encrypted file store. We receive confirmation in the new public key. Next, I open the transfer intent file. I update the field to the newly created wallet address. I copy the public key of an existing funded wallet and set it as from wallet ID. I increase the transfer amount. Then I'll execute the intent runner. The execution pipeline runs validation to policy, evaluation to transaction build, to sign to send, to confirm. Execution completes successfully. Now I list wallets again, npm run wallets -- list. We now see 4 wallets. The newly created wallet has received 0.0010 SOL. The funding wallet shows the deducted balance. This confirms wallet creation, secure storage. On-chain transfer, balance tracking, all operating through the same autonomous execution pipeline. Now I will intentionally violate a policy. I increase the transfer amount significantly to exceed the configured spending limit. I run the same command again. The intent passes validation, but during policy evaluation, the spending limit policy evaluates the projected amount. The executor logs policy denied intent. The denial includes policy ID, spending - limit. Reason, spending limit exceeded. Projected amount exceeds configured limit within the current window. The raw intent runner then logs execution failed. Error code, policy_violation. No transaction is built, no signing occurs. Nothing is sent to the network. The wallet remains secure. This demonstrates that agents cannot bypass governance constraints. In this demo, we demonstrated A modular, layered architecture, AI-compatible intent, execution, secure key isolation, real Orca Whirlpool, DeFi interaction, wallet lifecycle management, multi-policy enforcement, deterministic denial of unsafe actions. The system provides a secure and scalable foundation for autonomous AI agents interacting with DeFi on Solana.